and hear me? Okay, in today's session, we are going to can anybody tell me what is a database? Like in general terms, what do you mean by database? You can type. Meanwhile, a database is nothing but a collection of stored information. Yes, right, as I have got one answer, collection of interrelated data, or it is a collection of stored information and records. Now, the information which is stored in a database, it is not stored like in any manner. It is stored in some logical manner. The data, the records, they have some logic in which they are stored in a database. So it is a collection of information that we can retrieve from the database and we can use it for our computations. I am sorry for these slides. I think the contents have moved from one place to another. I will send you a proper document later, but meanwhile we have to manage with this. So as you can see here, any computation, it requires data. But if that data is not stored properly or is not in some logical manner, it is of no use. So it is better to organize that data into some database so that that data becomes meaningful and we can use that data for the computations as per our needs. So whatever data is stored in a database, it enables raising queries. We can raise queries, we can retrieve data by raising queries. We can do many transactions like updating the records, adding the records, inserting new records, deleting the existing records. These are the operations that we can do on the data which is present in the database. So a common example of database can be a contacts database. In a contacts database, what we do, we have contacts. Under those contacts, we can save the name of the person, we can save the telephone number of the person, we can save the mobile number of the person, we can save the, say, office telephone number. So these are all the records that we can save under the contacts database and not related to one person, to multiple persons and in some logical manner. As I said, you can see it is a collection of systematically stored information, records. It is not just stored in any manner, it follows some particular logical manner. Now, the database can be of two types as per mobile computing. Like this database, the logic is same like we have read in database management system and all, but here we are talking about database in context of mobile computing. How we can retrieve the data from the database to use for computations for our mobile devices. So here we can store the data in form of lookup tables and we can store the data in form of tags. So lookup tables, what are lookup tables? Lookup tables are those databases that store information in a tabular form. Tabular form means it has rows and columns. So the first column of the table provides the reference for the data and the subsequent columns, they provide the data. So this is what lookup table is for. As you can see here, lookup table stores information in a tabular form. First column, I think you all know the structure of how the table is formed in rows and columns. So the first column gives the reference to what the following data is, and the subsequent columns gives the data related to that reference. And the reference, it is a key to the data values. Now, tags based database. This is also a logical structure which is based on tags. Tag is nothing but a key to the data value. Here you can see one example. Here we have contact 1 John, 2 Lucy, and address ABC Street and 2 DEF Street. Here contact and address, they are the tags in the database. So if you want to retrieve some data, suppose you want to retrieve the contact of John, so you will use the contact tag, and if you want to retrieve you will retrieve the address by using the address tag. This is what tag-based database and lookup table database is used for. Now, as I told you, the data which is stored in a database, it follows some logic. It is stored in some logical manner in the database. So there are some computations or transactions that are carried out. So the logic that we are talking about, what is that logic? Business logic is a way in which the transactions or the computations are carried out between two entities. The two entities can be the client or the server. The two entities can be the database and the client server, or the two entities can be the database and the application interface. So this is what the business logic is. So using this business logic, we can make many computations. Like I told you before, computations can be connecting to a database or ending the connection with the database. Another computation can be, we can query the database for retrieval of some information, and we can update records, we can insert some record to the database, we can delete some record from the database, we can modify records, we can insert records, we can append records. These are all the transactions that we can make on the database using this business logic and the data that is present in the database. Any doubts till now? If you have any doubts, you can type in the chat window. So till now we have seen what is a database, how the data is stored in the database using the business logic. There are two ways we can store data. One is lookup table, second is using tags. And what is business logic? Now we come to transaction command. It is a command which we send to the database for retrieving the data. And this command, it has the logic in it according to which the data stored in the database is retrieved. So this command is sent to the database for retrieving the data for computations. This I have already told you that the data stored in the database follows logic. It indicates the way in which transactions are carried out, and the transactions can be carried out between two ends. This I have already told you. Okay, application program interface. This is an API. It is used to run on an application. This section of the program, it is a software which is required to run an application. It can run instructions. It retrieves the records from the database. Like this, the client server concept will come further, but like in general terms, if I tell you, this API, it acts as a client. It sends queries to the database to retrieve the records from the database. So it acts as a software which runs on the applications to retrieve the records and to run the application. Here you can see in the figure, this is an architecture. This is a mobile device API. As I told you, application interface, it is used to retrieve the data from the database. So this interface, it is directly connected to the database, and it will send queries to the database in form of some commands like transaction commands, like I told you. It uses certain protocols to connect with the database, and the database, as per the request received by the API, as per the request sent by the API, the database responds accordingly. It sends the required data or the information to the mobile API for further computations. This is all I already told you, transactions involving database, establishing connection between API and the database, updating records, querying for records, terminating the connection, and previously what I told you. These are all the transactions that are carried out between the two entities, database and the API. Now, as I told you, business logic. So business logic is of two types, implicit business logic and explicit business logic. What is implicit business logic? When we take the data or components from within the database without using any external functions or queries, that logic is called implicit business logic. Means we do not require any external queries to retrieve the data from the database. The data which is existing inside the API is sufficient for the user to retrieve the data required by the user. Simple example of implicit business logic can be a telephone directory. In a telephone directory, what happens? The records, they are arranged in an alphabetical order. So we don't need to apply some external logic from our side. The logic is already applied. As you can see here, telephone directory, what happens? They are all arranged in alphabetical order. So whenever we search for some particular data, we just go to that particular alphabet and we search for the data. We don't need any external query. The names, they are structured in form of rows, and each name, like it has a corresponding telephone address, telephone number and an address. So whichever record, whichever person's record we need from the telephone directory, we can just use the implicit business logic and retrieve the records. There is one more way of retrieving the records. We can search the directory in the XML database. They are also arranged alphabetically. It uses XML. Since this database is designed using XML, so we use tag as a key. This key enables the business logic. We can do transactions on it. All the transactions, like I told you, updating, retrieving, addition, appending, etc. can be done on it. So this is the way in which the database in XML looks like. So here we can search the record in this manner. We have to use greater than, less than, like these signs to use. So suppose we need the first character of the search to be R. So we need all the names whose first character is R, whose name's first character is R. So we will use this command, and whatever records are there, it will be reflected in your screen. So this is the way, and that person, see, the records have displayed and that person's address and telephone number has also been displayed. So this is one way of how we can use XML database to search a directory. Now we want names that start with S. Here, as you can see, there are no names which are starting with S, so it is not giving anything. Explicit business logic. Implicit business logic comes from within, but for explicit business logic, we need some queries and procedures to define the logic. So we need some external queries which will be explicitly defined, and those can be used to retrieve the records from the database. So the transaction between the API and the database uses explicit business query. Here you can see this is an example of explicit business logic. Here we are writing a query to retrieve the records and accordingly to perform some actions. So the query is if the structure is equal to most recently added entry and the content type is English, so we need to retrieve only English records, and the query is like the flight origin should be Frankfurt and the airlines should be, they are giving the airlines and they are giving the each name, like it has a corresponding telephone number and an address. So whichever record, whichever person's record we need from the telephone directory, we can just use the implicit business logic and retrieve the records. There is one more way of retrieving the records. We can search the directory in the XML database. They are also arranged alphabetically. It uses XML. Since this database is designed using XML, so we use tag as a key. This key enables the business logic. We can do transactions on it. All the transactions, like I told you, updating, retrieving, addition, appending, etc. can be done on it. So this is the way in which the database in XML looks like. So here we can search the record in this manner. We have to use greater than, less than, like these signs to use. So suppose we need the first character of the search to be R. So we need all the names whose first character is R, whose name's first character is R. So we will use this command, and whatever records are there, it will be reflected in your screen. So this is the way, and that person, see, the records have displayed and that person's address and telephone number has also been displayed. So this is one way of how we can use XML database to search the directory. Now we want names that start with S. Here, as you can see, there are no names which are starting with S, so it is not giving anything. Explicit business logic. Implicit business logic comes from within, but for explicit business logic, we need some queries and procedures to define the logic. So we need some external queries which will be explicitly defined, and those can be used to retrieve the records from the database. So the transaction between the API and the database uses explicit business query. Here you can see this is an example of explicit business logic. Here we are writing a query to retrieve the records and accordingly to perform some actions. So the query is if the structure is equal to most recently added entry and the content type is English, so we need to retrieve only English records, and the query is like the flight origin should be Frankfurt and the airlines should be, they are giving the airlines and they are giving the flight origin and the present time and status. So if the records are according to this manner, like all the records are matching, so they are asking to get the records. Means we are using an explicit query to retrieve the records and then performing the action. They have given the conditions that flight origin should be this, the airline should be this, and the present time should be this, and the status. If it is not arrived, then we need to get the records. If it has arrived, then we need to delete the records. See, here we are seeing if the status is arrived, then we need to delete the records. Here, get records, as I told you, get records and delete records, they are the two procedures that carry the transaction. Now the connectivity protocol. Do you have any doubt till the business logic? No doubts? Okay, connectivity protocol. See, connectivity protocol, it is a way to provide access to database and to retrieve the data from the database. Like this protocol tells the method of how to connect and how to access the data from the database. It connects to client or server, the database. Like if we don't have connectivity protocol, the API cannot connect to the database. Like you saw one picture, we have an API, then we have a database. In between, I told you that there are some protocols which are used to connect to you, which are used for the connection between the two entities. So this is that protocol, connectivity protocol. It establishes a connection between the API and the database. It provides the connection and it also provides some commands. It tells the methods and it tells the order in which we can execute our commands so that we are able to retrieve the data and establish connection between the two entities. This is the same thing which I told. So there are mainly 2 to 3 functions of connectivity protocol. First, to establish connection between the API and the database, to give a set of commands, to tell what all commands should be executed and in what manner to retrieve the data from the database. Now these are some examples of connectivity protocol. You must have heard about JDBC, Java Database Connectivity, ODBC, Open Database Connectivity, Simple Object Access Protocol, and we connect the server to the database. Using these protocols, the connection can be established. Now, relational database. Relational database, it is a database which follows some relational model. Like the databases are in form of rows and columns. So there is some logical manner, relational logic, which this relational model follows for organization of the data, and it helps the database designer to present the information in a logical manner and in a more representative manner. Here, the relational database, it follows some logic and it uses the data which is stored, it uses some n array relation, means the data can be, if n is 2 it is binary, if n is 3 it is ternary, and in this way the data is stored. So here, by relational database, what we mean by this here, it means in mobile computing, relational database stores the data in a model which gives answers only in two forms, either true or false. We cannot have any third output like null or not defined. So the answers are in two value predicate logic only. This is the main thing about relational database, that it stores the data and it models the database in such a manner that the answer to the relational equations can be either true or false. As you can read here, there are only two possible results on evaluation for each proposition, true or false, and no third result, null or unknown or not defined, is not possible here. Now we have relational database example here. IBM DB2 every place DB2E is an example of relational database. It is a relational database engine. It needs a memory of 100 KB and it is designed to reside at the device. The size that this database can support means this engine, it can support databases of size 120 MB, and whatever enterprise server employ these databases, they deliver and synchronize the local copies of the data contents at the mobile device. So like you saw API, what it does is it synchronizes the local copies retrieved from the database and it sends these synchronized copies to the mobile device. This is in this slide, this is all told about the synchronization. It is saying that databases at the synchronization application or enterprise server, these DB2E database, it can be used at different layers at synchronization, application and enterprise server. What does it mean? By synchronization, we mean that if a data record is modified at the server, then the same records will be reflected at the client side. Here, as you can see the picture, previously the picture was about the mobile device API was directly retrieving the data from the database, But here, now what it is doing, the DB2E is connected to the database. It retrieves the data from the database, and this database engine provides the data to the mobile API. Okay, I'm really sorry for the slides. This summary is about the previous topics that we read. So let me summarize. We read about what is database, then business logic, then the transactions that we carry between the database and the API. Then we looked into the implicit and the explicit business logic. Then after that, we had some protocol, connectivity protocol, and the transaction commands that are used for retrieving the data from the database. Then the relational database model. Okay. Any doubts regarding section 1? No doubts? And should I continue with data hoarding and caching? Guys, reply. Should I continue? Okay. I am continuing with data hoarding and caching. Okay. See, a mobile device, it doesn't have a large memory. Like the memory that is there in our mobile devices is limited. So we cannot store large databases in our mobile device due to memory constraints. And like for every computation, it is very difficult to retrieve the data from the database, like for every time due to time constraints. So what is done is these large databases, they are made available on the servers or remote computing devices or network from where we can retrieve the data and use it for computations. Now, this mobile, like a specific data, it caches a specific data which may be required by the device for future computations, and it keeps it into the device, and this caching is done at the time when the mobile device is connected to the server. By caching, what we mean? By caching, we mean saving a copy of a particular data from a large database which is available at the server and when the mobile device is connected to the server. Understood this point? Like why we have done caching of data? See, the data is available in a database and those databases are very large in size. So we cannot store those large databases in our mobile device because our mobile device has a very limited memory. And we cannot connect to the database every time for every computation because there are some time constraints. In order to overcome this issue, what was done, the databases were made available on servers which can be accessed by the mobile device. So when the device is connected to the server, it takes the information required for future computations and it takes that information and keeps it with the mobile device. So when the device is not connected to the server and some data is required for computations, so what it does is the data that it saved At the time when it was connected to the server, it takes that data and performs the computations. This is the main reason why the data hoarding and caching takes place. So the data is cached and this data cache is hoarded into the mobile device. Now this data hoarding, it makes sure that whenever some computation is required to be done and the mobile device is not connected to the server, that particular computation is performed by the data that the mobile device cached when it was connected to the server. This is the main basic thing about data hoarding and data caching. See, for better understanding, we can read this. A mobile device cannot store a large database. Retrieving the required data from the database during every computation is impractical due to time constraints. Here in this slide, same thing was written, that the device, whenever it is not connected to the server, it caches the data, and whenever it is required, it uses that data for computation. Now, which is not valid anymore. So we need to check for consistency in case of hoarding. This figure I already explained to you. This is architecture of the tier 2 architecture. This is the tier 2 architecture. Now again we'll go back to this. This architecture, what it is doing, it has the data caches at the mobile device, and you see this is a figure of a process which has cache memory, and they are using the shared memory. So this thing, this picture and this picture, they are identical. See, they are equivalent. The data cache at the mobile device is equivalent to the cache memory at the processor. Now prefetching. What is prefetching? Prefetching is nothing but it is an alternate way of caching the data, which requires requesting the data or pulling the data records that may be required for future use. Prefetching, alternate way of caching the data, and the process of caching the data can be, the process of prefetching can be requesting for records or pulling the records which may be required for future use. Prefetching has some advantages. First, it reduces the server load. Then it reduces the cost of cache misses. Cost of cache misses means there may be some data which is not found in the device database, like in our mobile database when we need it for computation. So the time taken by the user or the client, the time taken by the client to access that data from the server is called the cost of cache misses, because the more time it will take, the more disadvantageous it is for the user, because there are some time constraints. So if we prefetch the data instead of caching the data, we will not get this disadvantage. Cache consistency, as I told you before, it is also called cache coherence. It makes sure that the data which is retrieved from the server is identical to the data which is cached at the mobile device. And it also makes sure that the data that we are using is valid and perfectly fine for the computations to be made. I told you one more thing related to the cache invalidation mechanism. Sometimes what happens, the cache record at the client device may be invalidated. Same thing that I told you before, that the data may expire or it may be modified at the server. But how will the client know that the data is modified or expired from the server? Cache invalidation mechanism is a mechanism which tells the client that the data has been expired or it has been modified, and it asks the client to use the new data for the computations. See, same thing. The data at the client side, it becomes invalidated or unusable, and the mobile device cannot use it for computation. So this information is conveyed by the cache invalidation mechanism to the client that the data has been invalidated and you need to use the other data that has been modified. These are the states. Okay, there are there are four possible states that the data can be in. First is the modified state. M stands for modified. E stands for exclusive. S stands for shared, and I stands for invalidated. Okay. I just want 1 minute break. I'll be back. So I'm starting again. Modified means, as I told you, this in this state it tells that the data has been modified at the server end, and the mobile device needs to use the mobile device needs to use the modified data for the computations. E stands for exclusive. Exclusive means the data is for internal use only, and it caching. Then we saw the architectures, two-tier, multi-tier, one-tier architecture. Then the somewhat the client server concept, the database resides at the server and the copies of the database are cached at the client. And these pages are not moving. These pages are not moving. Now, client server computing. Now we have, suppose we have a network, and in that network we have nodes. Nodes can be a computer or any other computing device. It can have multiple computers. It can have many other computing devices related to the computer. So in a client server computing system, a node can either be a client or it can be a server. So a client, it performs the actions as per the resources it gets from the server, and the server has more resources and computational power as compared to the client. On the other side, if we see to the distributed peer-to-peer system, it is designed in such a way that each node in a network has similar kind of resources and they depend on each other for the resources. So here we are going to look into client server computing. As I told you, client has less resources than server and it depends on server for the resources. So what a client does is it requests the server for data, and the client can either access the records and save it to the list of database. See, a client can either access the server and save in its own database, or what it can do, it can select the records from the server's database when the server broadcasted the records. A server can broadcast the records or it can not broadcast. So in case it is broadcasting, the client can select the records and save it. And the other way can be the client can directly access the server and it can save the records into its database. Like we had coding architectures, here we have client server computing architectures. Here also the architecture is an n-tier architecture. N can be 1, 2, 3 and so on. When the client and the server, they are on the same system, then n is equal to 1. When the client and the server, they are on the different systems, then n is equal to 2. When the server connects to other tiers or other systems to provide additional resources to the client, then n becomes greater than 2, and n is greater than 1 when the client at tier 1 connects to the server at tier 2 and server can further connect to higher level tiers. See, now the architecture of the tier 2 client server computing. See, here you can see, just concentrate on this image. The application server is at the tier 2. Here you can see in the image tier 2 application server using business logic. Okay, so what it is doing, this application server, it is using some business logic to retrieve the data from the database servers, and it is using the connectivity protocol to connect to the server, and in return, after retrieving the records from the server, this application server is providing or updating the records at the local copies which are present at the mobile device. So at enterprise, any enterprise has a database backend. So there can be many types of databases. It can be Oracle database, it can be IBM DB2 database, it can be XML database server. So these all database servers, they are communicating with the application server. Their application server is acting as a client, which is asking for the data from the server, and in return, the server is providing the data to the client, and client is providing this information to the mobile device. With that, are placed at tier 1. This is the architecture of the tier 2 client server computing. Here it is telling about the synchronization and all. which it follows. The application server, it has some synchronization mechanism and it has some business logic. So what it does, it synchronizes all the data which it is sending to the mobile device through the protocol that it is having. Now 3-tier architecture. 3-tier architecture, it has, as you I will show you the picture of the 3-tier architecture. So this is the 3-tier architecture. Whatever was there in the previous slides is the theory that is being written about the 3-tier architecture. Somebody is saying that audio is not clear. Are you able to listen? Okay. So in 3-tier architecture, we have 3 levels. Level 1, mobile devices. Level 2, same as application server, synchronization come application server. Tier 3 is enterprise database server. Now, the enterprise database server, the enterprise server is connected to the database through the connectivity protocol. This now, like I told you, there can be multiple types of databases at the back end. So this enterprise server is related to these databases and it is connected to these databases through the connectivity protocol. So now it retrieves the data from the database, the enterprise database server, it retrieves the data from the databases as requested by the client, and this data is sent to the mobile device at tier 1 through the synchronization come application server. Now this synchronization come application server, it uses some business logic to send the data to the mobile device, and it synchronizes this data in such a way that the data that is received at the mobile and at the server is like identical, and if there are any changes at the server side, then those changes are reflected at the mobile device. So this is all about the architecture at tier 3. Tier 2 doesn't have any enterprise database. Directly the application server is communicating with the database. In tier 3, we have an enterprise database server which is communicating with the database and it is sending the data to the client, and client is further synchronizing it and sending it to the mobile device. As I told you, the enterprise server, see, there are some protocols between each level. We have connectivity protocol between the enterprise server and the database, and we have some other protocols between the enterprise server and the synchronization come application server. IIOP, JNDI, these are used for connecting between the providing connectivity between the synchronization and the enterprise protocol, enterprise server. And in case the application client is at tier 1, then we can use the HTTP connectivity to connect to tier 2. Now we have N tier. N tier means if N is greater than 3, then we use in between layer mechanism to give the data from the database to the mobile. An example of N tier can be 4-tier architecture, in which client device connects to the data presentation. I'll show you the image. See, sorry. Here, mobile device, it is connecting to the presentation server at tier 2. Presentation server is in turn connecting to synchronization cum application server at tier 3, and then synchronization server is in turn connecting to the enterprise database server at tier 4. So in this way, the tier 4 is connecting to database. Tier 4 will send the database to the mobile device through synchronization cum application server and application server. In this way, the mobile device will get the data. Now see, in our mobile device, we have a number of interfaces. We can have a calendar, we can have contacts, we can have Outlook, we can have Lotus Organizer. We have all these interfaces. So when we want the data from the server, the data format may not be the same as required by the mobile device. So to overcome this problem, we use adapters. These are all the interfaces that a mobile may have. So there may be differences in the form of data transmitted from the server and the data that may be required at the device. So this is the requirement of the adapter, so that whatever data governed by some protocol needs to be converted to the another protocol which is used by the mobile device. So we use two adapters. It is adapter means it is a kind of which is used for data format conversion. So one adapter is for standard data format that is present at the mobile device, and another adapter is for the backend database which is in a different data format for the API at the mobile device. So one adapter at the database end, the data will come, the adapter will check it, it will send it to the mobile device. The adapter will check and adapt that data as per the mobile device and will send it to the mobile device, so that there are no format problems occurring in the entire process. As I told you, it is just a software, adapter is just a software to get data in one format and convert it to another format by the data governed by the another protocol. Because both the ends are using different protocols at both ends, so we need to use these adapters to make the data adapted to the mobile device. Here, as you can see, this is one adapter which is placed, and this is another adapter which is placed. This is for mobile device, this is for the backend database. So whenever the data is retrieved from the database and it needs to send to the mobile device, it is first synchronization adapter is placed here for adaptation of the data. Then here it is adapted as per the mobile device protocol. They are also adapters. They are also used for interchange between standard data formats and the data formats for the API. The formats can be interchanged. Now, these are some of the some of the companies that are providing adapters. IBM WebSphere Everyplace Access it provides adapters for synchronization objects and bases as well. So this is the summary of the topics that we read. We saw what is client server computing. Then we saw the architectures of client server computing. We have tier 1, tier 2, tier 3, tier 4, and tier architecture. As per the tiers, the data is retrieved according to the tiers. The data is retrieved from the database and it is sent to the mobile device through various levels of the architecture. And then we use adapters for and then we have data. We saw data architecture of distributed caches also. Then we had MESI protocol, cache invalidation techniques, cache access protocols, etc. So I am done with today's topics. If you have any doubts, you can please ask. Any doubts? I'm sorry, but the download option cannot be enabled because I'm using the browser version actually. So I think it is not possible to enable the download option here. This document. And anyways, this PPT was perfectly fine in my system, but after uploading here, the contents have moved from one place to another. Okay. IIOP is nothing but an Internet Inter ORB protocol. It is a protocol only, which is used for connecting between the two tiers. The full form is, I'm typing here, Internet Inter ORB. ORB stands for Object Request Broken. It is a protocol for connecting between the application synchronization server and the enterprise server. Okay, anything else? Can we wind off the session or still I can still clarify your doubts if you want. Are you referring to some book related to this mobile computing?